All right, here we are with Unit 6. Unit 6 begins with logs. A lot of these problems have to deal with exponents and these things called logarithms. Logarithms. So let's take a moment and learn some basic things about logarithms and what we kind of need to know. Now, you'll notice on our calculator, I'm not exactly, I think it's under the function. Okay, under the function, there's this log button, and log buttons are found on a lot of different calculators. Okay, and it's literally just the word log. Okay, and so this is a logarithm. What this does is it allows you to kind of investigate and do things with exponents kind of in an easier way, or it uses the calculator's abilities to figure things out. All right. So how to set up a logarithm. So when I see a logarithm, how do I understand what it is and how can I rewrite it? Okay, so let's start with something very basic that we hopefully know. 5 to the second power is equal to 25. Okay? Now, there's some nomenclature, some vocabulary that goes along with it. This is called the base, and this is an exponent. Okay, and that's a product. All right, a base and an exponent. Now, I want to really focus on the base because if I were to write a log, okay, if I were to write a log, there's numbers that go right here. There's a little teeny tiny like subscript number. There's a number that goes inside the log itself, and then it has a solution as well. So there's numbers that go in these places. All right. And this little number is called the base number of a log. And the thing is the base is the base. The base is the base. So if I were to be writing 5 to the second power is equal to 25 as a logarithm, this base would be 5. So it's a little subscript number next to the log. So that base is 5. All right, so the base drops. Boom. Okay, let me do that in a different color. So the base just drops down. Okay. Then, well, what goes in the other things, okay? So we still have this 2 and this 25 unaccounted for. What they do is they switch sides. So this 25 goes in here, 25, and this would be 5. So log base 5 of 25 is equal to 5 is the same thing as saying 5 to the second power is equal to 25. Write a different example. 2 to the third power is equal to 8. All right, so again, this is the base. So this is going to be log base 2. Okay, log base 2. So it's a little 2. Everything switches sides. So the 8 comes to the left and the 3 goes to the right. Okay, and then you can naturally rewrite this back in what is known as, so this is called logarithmic. And logarithmic notation, I might have misspelled that, but logarithmic notation. And this is called exponential notation. Okay, exponential means it's written with exponents. Logarithms means that it's written with logs. And you can obviously recreate the exponential. So this is the base, so that's that. Then everything switches sides. So the 3 and the 8. So the base is the base, is kind of how I remember what to do with logarithms to exponents, etc., etc. Okay, and then we're going to learn how to use our calculator. But that isn't until a little bit later in these problems today. So let's get going. So they want us to begin by write the equation in logarithmic form. Okay, so you write these as logs. So the base is 5. So this is the base, 5. Okay, everything switches sides. So the 125 goes left and the 3 goes right. Okay, here we have the base number being 8. So that's log 8. Okay, everything switches sides. The 64 comes over and the 2 moves as well. Here we go. The base is 10. So this is log base 10. And then the 1/100th comes over. -2 goes over. So the base is the base. Right? So the base is the base. Everything switches sides. You get the idea. Everything switches sides. Okay, now they want us to write this as an exponential form. Okay, so here we see that the base is 5. The base is 5. All right, so the -1 comes left and the 1/5 goes right. Okay, again, write this in exponential form. So we see that the base is 6, the 3 comes over, and the 215 goes over. Right, in exponential form, the base is 36, -2, 1/6. This is not a true statement, by the way. Okay. Evaluate the following without using a calculator. All right, so what is the answer to this? Okay, that's the question. What is this equal to? And so what I do is I kind of think of this as being equal to something unknown, like the letter X. And then I rewrite it. Right, so I see that the base is 5, so 5 to the X is equal to 625. So I need to figure out what power of 5 will equal 625. So let's just kind of play along. So 5 to the 1. No. 5 to the 2. No. 5 to the 3. Getting closer. 5 to the 4. There it is, 5 to the 4. All right, so that means this X is equal to 4. That's what the original problem is equal to. What is log base 5 of 625? It's 4. Okay, so again, this is equal to something. I need to figure out that something. The base is 13. So 13 to the X is 169. I think that's to the second power, I think. So 13 to the 2. There it is. Okay, so 13 to the second power. This is equal to 2. Okay, here they want us to use a calculator. Now, the problem is when I use this log in this calculator, it brings in a log and you get to put in a number like 333, for instance. But the problem is it doesn't allow you to give it a base. And so these answers are going to be different. Okay, these answers are going to be different. So how do I write like a log base 5 of 333 instead of just log 333? Because again, when you hit the log button in your calculator, it just throws in just a basic log and you're not able to change that base. All right, so here is where you have to know how to change the base yourself. So right now, this problem is chilling with log base 5 of 333. here's what you do to change the base and ultimately use your calculator. What you do is you turn this into a division, okay, cutting off that base number, and then you throw a log of that base on the bottom. Okay, so let me show you a couple examples. Like if I need to know what's log base 3 of 124 or something like that. Again, I cut the log and I put a log on bottom. So it turned it into a division. So this is ultimately log 124 divided by log 3. Right? Log 124 divided by log 3. All right, so here this is log 333 divided by log 5. I'm not exactly sure how closely they look at it, but I would really probably encourage you to use parentheses. So log 333 divided by log 5. And so we see that this result is 3.60, oh, 2 decimal places, 3.61. Because again, that was 3.608, rounding to 2 decimal places, that rounds to a 1. Here we have log of 1/3, log of 1/3. Okay, so here we really don't have a base to worry about. We can just kind of type it in. So log of 1/3. That's negative 0.48. Okay, if you see a log that doesn't have a base, like we do here in number 10, technically a log that is just a log technically has a base 10. Technically has a base 10. So if you really, really, really wanted to rewrite this, this would be log of 1/3 over log 10, and you'll get that same answer. So this would be log, sorry, I meant to be typing in the Desmos. Here we go. Log 1/3 divided by log 10. Okay, so you get the same answer. So logs that are just sitting there, like the log that's in your calculator, is technically a log base 10.